Hey grade 11s, so today we're going to be looking at the lungs helping with homeostasis. So I'm sure you remember doing all of those negative feedback loops. We are going to take a quick look at how to do that with the lungs, but we're going to do very basic negative feedback loops. So if you're thinking, oh, Miss Graves, we did so many of these when we learned about homeostasis, we're just going to do very basic ones for respiration. So how do your lungs help with maintaining homeostasis? Well, your body has a specific amount of oxygen dissolved in the blood as well as levels of carbon dioxide. When these levels are off, your body reacts to fix it. You have hundreds of chemoreceptors throughout your body that monitor your blood carbon dioxide, which is acidity, and oxygen levels. So it's those chemoreceptors right here, this chemoreceptors word, that are actually located in all of your blood vessels around your body that help to monitor carbon dioxide and oxygen levels in your blood. So we're going to talk about both carbon dioxide negative feedback loops and oxygen negative feedback loops, but they're more likely, or it's easier for them to detect carbon dioxide because it really increases the acidity. So we'll take a look here. Carbon dioxide negative feedback loop. So you are going to draw something simple as this. I really don't want you doing the whole negative feedback loop with all the different parts. We just want to get the basic idea for this. So blood carbon dioxide levels increase, meaning that your blood is acidic. So after this initial step happens, we come over here. Your chemoreceptors, again, chemoreceptors are what are going to detect blood pH level changes. So your chemodetectors are alerted, or they notice that your blood pH level changes. They then send a signal to the medulla in the brain. We're going to talk about the medulla later, so don't worry too much about that term right now. We'll talk about it in a different unit. So the chemoreceptors detect the blood pH level change, and then the medulla in the brain sends a signal to the diaphragm to adjust breathing. So it's our medulla that is signaling a change in our diaphragm, which will adjust our breathing. And then our blood levels will return to normal by the breathing rate increasing and bringing carbon dioxide out of the body quicker. So if you are breathing quicker, you are more quickly expelling carbon dioxide from your body. So your blood levels will return to normal. And then potentially you have acidic blood again, chemoreceptors notice, your medulla adjusts your breathing rate, and you breathe quicker to bring carbon dioxide out of the body quicker. So just in case you were wondering, there's a little key down here. So your receptor is the chemoreceptors. Your control center is the medulla. This is incorrect. I'll change that quickly. I'm not sure why that says pulmonary capillaries. And then the effector would be your breathing rate / diaphragm. So make that change. I'll change that in the notes as well. So anyways, this is just a very brief negative feedback loop. So make sure you understand this. And again, we don't need all of every possible moving part in this. It's just this very basic negative feedback loop. So after we've looked at a carbon dioxide negative feedback loop, we will take a quick look at the oxygen negative feedback loop. So here it says blood oxygen levels decrease. So again, this is a little bit trickier for the chemoreceptors to notice because carbon dioxide makes the blood quite acidic. So it's harder for them to notice when the oxygen levels are decreasing because it's easy to notice when carbon dioxide levels are increasing. Okay, so this is less common. This is the most common way that the lungs will work with homeostasis, but this happens sometimes too. So anyways, blood oxygen levels decrease. Chemoreceptors detect the blood pH level change. Again, chemoreceptors are always detecting the pH level of your blood. The medulla in the brain sends a signal to increase the heart rate. So this one doesn't quite go to your lungs as much. This one goes more to your heart rate. And then blood oxygen levels return to normal with more oxygen in the blood when the heart beats faster. So the medulla is telling your heart to beat faster so that more oxygen can be brought in. So this one looks more at the pulmonary aspect it's way less focused on the lungs, obviously. I don't even think the lungs are really in here, but it's important to understand when we're talking about oxygen and carbon dioxide how this would work. So we'll just take a quick look here. So again, our receptor is always these chemoreceptors. Our control center is our medulla in the brain. And then in this case, our effector is the heart. So I want you to focus more on this carbon dioxide negative feedback loop, less on this oxygen one, but I just think it's important for you to know both case scenarios. Okay, so that's how the lungs help with homeostasis. If you have any questions about these, please let me know. And make sure you make this little change. I'll change it in your notes, but make sure you make that change as well.